Okay, so 10-2. We are doing areas of trapezoids, rhombuses, and kites. What makes something a trapezoid? So that's this picture that we're looking at, right? That's a trapezoid. How do you...
One side's longer than the other.
You will have a side that's longer than the other, yes. What is true of those two sides?
I don't know. The angles are the same.
They're parallel. Okay, so a trapezoid has exactly one pair of parallel sides, right? So we're looking at this. In this setup, you have three different components that come into play, okay? The formula for this is 1/2 times H times B1 plus B2, okay? Put your Clash of Clans away. You don't even need an iPad. You have paper notes. Put them away.
Oh, yeah.
Put your Clash of Clans away.
I'll throw myself.
All right. So if this is your setup, H represents what, do you suppose?
Right.
The height.
Is that B1 or B2? Like B1 or B2?
B1 and B2. This is B1. This is B2. So B1 is just one of your bases. B2 is the other base. So this is a base. This is a base. The height has to be perpendicular, just like it was for a parallelogram, just like it was for a triangle. Okay, are you seeing a pattern? The height is perpendicular. So your height is going to be something like this. Rarely is your height a side of the trapezoid. It can be, like example 1, it would be, but unless it's perpendicular, it's not. Okay, so this is the formula, 1/2 times the height times base 1 plus base 2. And I will tell you right now, the place where most people make mistakes on this one is right here. I'm going to give you the formula. It is going to say 1/2 H B1 plus B2. And some of you are going to be tempted when you solve to do B1 times B2. So I just want to turn your attention to that is a plus every single time. Okay? You add your bases together and then you cut it in half. Okay? All right, so take a look at this first example then. This is a trapezoid, this whole big thing. These are parallel. Okay, what would you call H right now? $242. This is your height. Okay, it's perpendicular because this makes a rectangle here. So 242 is H. What would you call B1?
Wait, what was 190?
B1. B1 and B2 are interchangeable, so it really doesn't matter if you pick 190 or 250. Okay.
Wait, no, actually. 2 different lengths.
Right, B2 is this.
What do we B1?
The whole bottom piece. Right, this is B2. Okay, so if this is your information, set that up in the formula that I gave you. How would that look? A equals, what comes first? From this formula.
Half.
1/2. Yeah, half of what?
242.
The 242, so 1/2 H. And then what?
B1 plus B2.
Which is what in this case?
190 plus 150.
Plus 250, yeah. So 190 plus 250. Now get your calculator out because I want you to plug this in and make sure that you're doing this correctly, because honestly, a lot of the issues come with the calculator, I feel like. If you plug it in exactly how you see it, with parentheses, you will not get it wrong. But if you try and do it on your own without parentheses, you will get it wrong. So take your time.
Times 242.
Yeah, so if you want to plug this in as 0.5 and then parentheses 242, or you could go 0.5, the times button, 242, and then do parentheses 190 plus 250. That would be fine also. However you plug it in, you should be getting what as your answer?
53240.
53,240. And then how do you label area?
Miles squared.
Miles squared.
Oh, I got it wrong.
I'm actually so thankful at like.
You got what?
I don't know how he does all this.
Did you do 0.5?
Oh no, I did it right. I just thought I saw it
Oh,
wrong.
okay.
Who are you?
Questions on that?
Get the voices out of my head immediately.
Okay, now here's the deal. This one is a little bit challenging.
Where's the
I don't make you,
Where's the height?
Can you go back up to that problem real quick?
Yeah.
I don't have my calculator, so I just.
I don't make you do ones with 30, 60, 90 triangles in them on the quiz or the test, but I do have you do a couple in the homework just for practice, because you guys do know how to do 30, 60, 90s, right? But these are challenging, okay? Notice this says leave it in simplest radical form. Do you remember what simplest radical form looks like? If there's a radical involved, the radical should be part of your answer, right? Simplest radical form. Okay, so here's what I want to know. In this setup, if our formula is area equals 1/2 times the height times base 1 plus base 2, of all those variables, h, b1, and b2, how many of them do we know right now?
B1 and B2.
B1 and B2. I would call B1 5, but you could call it B2 if you want. I would call B2 7. Okay, so we have our B1 and our B2. The thing we don't have is our height, and that's right here. Now, if that's a 60-degree angle, this is a 30. So we have a 30, 60, 90. Can anyone tell me this length?
That's 2.
It would be 2. If this is 5, then this is 5, but the whole thing is 7, right? So this piece is 2. Do you remember in a 30, 60, 90, it was L rad 3 and 2L,
Oh.
right? So if this is 2, that's this piece. That's your L.
3.4.
So what is H
3.5.
in radical form? Did you plug it in?
Yeah.
Yeah, without plugging it in.
Just be 2 rad
It's
3.
2 rad 3. Okay, like I said, I will not make you do this on the quiz. I'll keep it a little more straightforward on the quiz, but I do want you just to draw from prior knowledge here a little bit. So if this is your setup, then my height is that 2 rad 3, okay? Now you should be able to plug stuff in. So you have, let me move this.
What? Do I matter? Like, what?
All right, so if we're gonna plug in, this is 1/2. What is H?
2 rad 3.
2 rad 3. And then B1, which is 5, plus B2, which is 7. Okay, here's where it's easy to make a mistake. If it's in simplest radical form, you don't touch the radical until the very end of the problem where you drop it into the answer, okay? So we're gonna ignore the rad 3 right now, and you're gonna plug this into your calculator. 1/2 times 2 parentheses 5 plus 7, or you could simplify the parentheses to 12 if you want. Just add it in your head. So when you do that, you get area equals 1/2 of 2 is 1 plus or times 12 is 12. Did you get 12?
I got 20. No, it's because I put rad 3 in the equation.
Yeah, don't plug the rad 3 in. So 1/2 times 2 times parentheses 5 plus 7, okay? You should get 12. Then you drop your rad 3 in. So it's 12 rad 3 square meters. Okay? Questions on that?
Is a question like this going to be on the homework?
There's just maybe one. I don't remember how many I did, but okay. Write this one down. I'm gonna have you see if you can find what you need here. Let's say this is 10, this is 8, and this is 12. Find the area of that trapezoid for me. You can use the formula because you'll have the formula in front of you for the quiz.
I should tell it.
I got it.
Don't say it yet.
I forgot how big it is.
Set that up in the formula. Label your parts. What's B1, what's B2, what's H?
Actually,
Is it 4 times 22?
1
You can look at it that way, yeah.
times
oh my goodness.
8.
Ask your soldier.
All right, so what do you get?
What? What was that?
What'd you get?
88.
88
Yeah.
square units, whatever they are. So it should have been 1/2. This is your height.
480.
That's 8. No. Did you put parentheses around 10 plus 12?
Oh, shoot.
Okay. So this is what you should be plugging in with the parentheses. So your answer is 88. And then whatever your units are, you square them. So UN squared if there's no units given.
Parentheses and the plus.
Okay. The plus, I'm telling you. The plus. Don't leave those parentheses and pluses on.
Area of a rhombus.
Okay, the other two formulas. And then we'll do, yeah.
Wait, we're doing more?
So that's trapezoid. And then rhombus and kite are what we're gonna do.
Potter room, you like shank someone with your wand.
Shank.
Like instead of like.
Okay.
using the wand, you shank someone.
What makes something a rhombus?
A rhombus is when it's. No,
Or
I totally forgot.
parallelogram.
Isn't it the.
Parallel slanted
with
sides.
No right angles.
It can have right angles, it just doesn't have to have right angles. What's the like definition? All the sides are equal, okay? It is a parallelogram with 4 congruent sides. So that's a rhombus. Does anyone remember what is true about the diagonals of a rhombus? They're not the same. They bisect each other. So like these are equal and these are equal. But there's something else that's true about their diagonals, an angle measure. Do you remember?
It's like 180.
I mean, each of those triangles would be 180.
Or,
No. The whole figure would add up to 360 without the diagonals. What's going on right here?
Oh, they intersect.
90, right? Your diagonals in a rhombus are perpendicular. So this is 90, this is 90, this is 90, that is 90. So those two things come in really handy in a rhombus, okay? Right angles help you because Pythagorean theorem will come into play. What's the Pythagorean theorem?
A squared plus b squared equals c squared.
Right. So if you're missing a side length, you could do the Pythagorean theorem to find a missing one. But here's the formula. You do 1/2 times diagonal 1 times diagonal 2. What's a diagonal?
Dakota, this is one.
No, it's
An
not.
acute or obtuse angle.
Is it like the red lines?
Yeah, it's those like maroon reddish colored lines. So this right here, okay, I would call that diagonal 1. It doesn't matter which one's diagonal 1 and which one's diagonal 2. And this one right here, I would call that diagonal 2. Here's what I want you to watch out for. Here's what probably the most common mistake that I see on these is people treat these as diagonals because they're on a slant. For some reason, people think of diagonal and they think of slanted, which I get,
How?
but it's not a diagonal, right? It's a side of your figure. The diagonals cut through the figure, okay? So do not use this. We don't want those as our diagonals. The diagonals have to cut through the figure, okay? Okay, so that's a rhombus. We'll come to that in a minute. We'll talk more about that in a minute. A kite. What makes something a kite?
When it
Isn't
goes
that
in the
360?
The whole thing will add up to 360.
Wait, is a
It'll
kite
be,
kind of a shape?
yeah, a kite is these two are congruent
I didn't know that. That's crazy.
and those two are congruent.
Wait, what came first? The toy or the shape?
Probably the shape.
What? That's I did not know
But
that.
then they designed a toy that's like that can fly based off that shape.
Yeah, cool, right?
That doesn't make sense. The kite came first.
I don't think so. I don't know that,
You should
but
Google it. Let's Google it first.
later, not right now. Okay. So here's the deal with a kite, okay? In a kite, there are several things. The diagonals of a kite are perpendicular. The diagonals of a kite are perpendicular. These lengths on a kite are the same. But
Oh, let's go. Forrest is right.
where are you getting that information?
Google.
Because a kite like this
Wikipedia.
is for sure
It says,
ancient.
The
So
kite that fly in the air came first, but the geometric one is a kite that. A kite is a quadrilateral with two pairs of congruent adjacent sides and no opposite sides.
that's the definition of a kite. Yeah. We'll talk about it later.
Let's go.
Okay,
We
so
win.
in this setup, these two pieces, the one that have the circles, okay, you with me? The ones that have the circles on them are not the same length. They cannot be in a kite. If it was the same length and the others were the same length, it would be a rhombus again, okay? I'm gonna show you on this picture where the formula comes from, okay? You don't need to draw this. I'm not trying to confuse, just watch. If I put a rectangle
No, do I have to do that?
around, no, that's why I said, don't do this, just watch.
You silly goose.
If I draw a rectangle around a kite, okay, think of it this way. If I want to know the area of the rectangle, right, I have a base and a height, and I would just go base times height. Now look at this. This length here, which we call a diagonal, we'll call it diagonal 1, is the same length as that right there, right? So the side of the rectangle is the same as the length of the diagonal. Now look at the other one. This diagonal is the same as the base. So I would call that the same as diagonal 2. So really, instead of base times height, which I had, I can go diagonal 1 times diagonal 2, and I would find the rectangle, but I don't want the rectangle. Tell me how this kite compares to the whole rectangle. Does anyone see it? This kite, how does this relate to the whole rectangle? What fraction of the rectangle is it?
Wait, wouldn't you just subtract because those are all triangles?
They are all
So
triangles.
you can just subtract.
Look at it this way. What if I just look at this little rectangle?
Oh.
The kite portion is how much of that rectangle?
Half.
Half, right? Now look at this rectangle. The kite portion is what fraction? Half. Now look at this rectangle. The kite portion is half, and in this rectangle, the kite portion is half. So every piece of it is half as much, right? So if I said I'm going diagonal 1 times diagonal 2, base times height, that's fine. That's going to give me this area, but I don't want that area. I want the kite, which is half. So it's the same formula, half of diagonal 1 times diagonal 2, the same formula that we just did for the rhombus, right? So kite and rhombus have the same formula. You don't have to remember all this. This is just helping you to see it. Okay, so here's what you need to know. You need to know that this would be diagonal 1. Excuse me. This would be diagonal 2, right? So we're going to multiply those two lengths. Diagonal 1 times diagonal. It's the exact same formula.
See.
So what was all that other stuff for?
I'm proving to you how they came up with the formula,
Oh, I just
right?
I thought we were gonna.
That's why I said don't write it down. You don't need to know this. You just need to. because you literally weren't listening to me when I said, don't write it down. Okay, this is still a right angle, so you still have the possibility for Pythagorean theorem, okay?
So this, we can erase like the little circle.
This is all you need,
Bro.
Oh my gosh!
which I said at the beginning, don't write this
I
down.
only heard you say that like before you like drew the square around it.
Yeah, that's
Everything
what I
else
thought.
was like, okay.
Well, yeah, all the other stuff is fine to have on there.
Okay, cool.
It's, I mean, that's essentially what I rewrote in. You can have all these, this is great, that makes it a kite.
Okay, cool.
Oh.
Leave all that, that's fine.
I drew the circles.
The circles you don't need. The circles was just so I could show you what pieces I was
I
talking
drew like
about.
the rectangle around it, and I scribbled it out when you scribbled it out.
Yeah, that's when I said, don't write this down, and you were turning around making weird noises at your friends.
I was talking. Oh.
Choices have consequences. Okay,
I was speaking.
so here are your two problems with this,
I was speaking my native language.
okay? This is a rhombus. What is the formula for the area of a rhombus?
Half
D1.
D1, D2.
1/2 of diagonal 1 times diagonal 2. Okay, in a rhombus, the diagonals bisect each other. So these are the same, and these are the same, right? This is one diagonal. This is the other diagonal. Is 15 part of a diagonal?
No.
No. 15 is a side of the rhombus. So the 15 does not get put into your problem, but you use the 15 to find the missing information. Can you tell me the length of either of your diagonals right now?
Nope.
Yes.
Which one?
Oh, the 15.
First one.
Not 15.
Dang it!
12.
The 12, okay. 12 is this length. This is 12. What is the length of the diagonal, the whole thing?
24.
24. Those are congruent, okay? So we're going to say diagonal 1 is 24. 12 plus 12. Okay, now here's where it gets fancy. Look at this. You have a right triangle with sides of x, 12, and 15.
Is it 13?
It's not 13.
12.
Yes, Pythagorean theorem. If you know two of the three sides of a right triangle, then you set it up in Pythagorean theorem. X squared plus 12 squared equals 15 squared. Why is the 15 the one by itself in Pythagorean theorem?
Because it's the longest.
It's the longest side. It's your C side. It's the one across from the right angle. Okay? So make sure that's by itself. And then to solve this, you're going to take away 12 squared. So you get x squared equals, remember this is not 3 squared. You have to plug it into your calculator, 15 squared minus 12 squared, and you should get 81.
81.
81. So x equals 81? Or just
No,
both
x
sides?
squared equals 81.
Cut 81
I'm gonna jump out.
Not in half.
Say that again.
Oh.
If you square something, how do you undo squaring? Square root. Okay, so that's your next step. You're going to square root both sides,
Good job, Forrest.
and x is 9. Okay, so here's the deal. This is 9. What is diagonal 2? What's your second diagonal?
9.
81. No.
12.
Not 12.
18.
Oh,
It's 18.
dumb.
This is 9, so this is 9 also. Add those together. So diagonal 2 is 18.
I'll get you. I'll bet you.
Okay? So here's what you do. The area of this trapezoid, not trapezoid, rhombus, wow, is 1/2 times diagonal 1, which is 24, times diagonal 2, which is 18. So plug that in. 1/2 times 24 times 18, and you should get 216, and then it's an area, so square centimeters.
Oh, you put parentheses around each one.
I mean, you don't have to. You can go 1/2 times 24 times 18. You can do the times button.
Chinese splendid.
Okay, so here's the most important piece. Your diagonals are not related to the 15. Well, related to, sure. You have to use the 15 to find it, but your diagonals are here and here, right? They cut through the figure. They are not sides of the figure. Good? Okay, last one. This one's the easiest for sure.
No way.
Okay, your formula is area equals 1/2 times D1 times D2. Can you tell me the length of diagonal 1?
7.
7 would work, right? This is 2, this is 5, so the whole thing, 5 plus 2, is 7. Okay, so we'll call diagonal 1 7. Can you tell me the length of diagonal 2?
6.
Your other diagonal cuts here. That's 3 plus 3.
Oh.
So 6. Okay. So what are you plugging into your calculator?
1/2 parentheses 7 parentheses 6.
Right. 1/2 times 7 times 6. So if you plug that in, you get 21
21.
square meters.
Oh, I understand.
Okay. Make sure your diagonals are here, not here, not here. It is never a side of the figure. Okay. The diagonals always cut through the figure.
Are we done with those?
Good?